here. Okay, so for this section, all we're doing is kind of formalizing the idea that a sequence lands only on integers. You can have a first term, second term, third term, and a fourth term, and so on. But it obviously follows a straight line. So we could write a function in function notation for this sequence as well. And it's nothing different from what we did before, where you convert point slope formula to slope intercept formula. So what you're about to see, you might question yourself and think, is this all I need to do? And the answer is, yeah, pretty much. Find the difference, which is the slope, and then put it in the point slope formula and convert it to slope intercept formula. That's it. So as we're going through this, just keep it in mind. They're going to ask the same questions many different ways, which they do. You got to know all the different ways, whether it's a chart, a graph, words, you got to know all the different representations. But in the end, it's really something that's quite straightforward. All right, so first we can start looking at this, and we can just tell from the graph right here at 1 that the answer is -5. That's why it says first term is -5. And you could write all of these right here as well. You could do it one, two ways. Just look at all the points and say, well, 2 is at -3. And then 3 is at -1. And at some point, you probably catch on, oh, I'm just adding 2, right? So that's the slope, which is also known as the difference. And just follow the pattern. Instead of looking at the graph, you could probably continue and come up with these no problem, right? So the formula that we used for a sequence, when they're talking about a sub n, they're talking about a sequence, so you want to use that formula. And in general, always use the first term, because it's point slope formula. You could really use any of these, but by default, we always use the first term. So I'm going to use -5. I know my difference is 2. And then n minus 1. If you're not given the first term, right, you could, this one is the same as this one. And this -5 is the same. Oh, I can't do that. Let's go blue. This -5 is the same as this -5. So if you're not given the first term, you could really use any of these terms. And if you go through and solve it for slope-intercept form, that's what they're talking about in Part B. They're saying write a linear function. So you go from a sub n, which is subscript notation or sequence notation, to function notation, which means you use a f of n instead of a sub n. And then just go ahead and distribute like we normally would, right? So distribute the 2, distribute that. So we have -5 plus 2n and minus 2. And then, much like slope-intercept form, it's y equals mx plus b, right? We're using n instead of x, but the point is, put this part first. So when you're looking at this, rewrite this as 2n and then -7. And that's your function notation. F of n equals 2n minus 7. So nothing you didn't do a long time ago in 8th grade math or Algebra 1. Just write in one format, distribute, and you'll combine those two numbers together. And of course, you might look at this and say, well, -7, that's like a y-intercept, right? Well, and of course, if we go over here and we work this backwards, we would get -7. So that's not a coincidence either that my n equals 0 term is my y-intercept. So all this kind of gels together much like it did in the past. So, and honestly, that's kind of what we're doing. We're doing different versions of this question over and over. So start by finding the difference, write it in the a sub n formula or the sequence or subscript formula, and then distribute and combine terms to get the function notation. Okay, so if we can handle that, we'll be okay. Now, they might give you like this chart where it's kind of, comes with a little graph, or you might be given something like this where it's a chart, no graph. So same question, just, different representation. So how would you find the difference, aka the slope for here? How do you suppose you do that? Yeah, just subtract those, top and bottom. As long as you remember how to do slope from a long time ago, you can find the difference. Don't mess up on negatives or anything small like that. It'll be all right. So we get, what is that, 56 over -7. So that comes out to -8. Right. now you can fill in all these just by doing -8 all the way through. So go ahead and do that. And afterwards, it just asks for the domain and range. So, of course, the domain is going to be positive integers only, also known as the natural numbers. Right? For sequences, there's no such thing as 1.2 or -5 or anything for the domain, because it stands for the first term, the second term, the third term. Right? And the range, of course, could be anything when you plug it into the explicit formula. So here, I think you end up with what? 17 minus 8 is 9, minus 8 is 1, minus 8 is -7, -15, -23, and -31. Which, of course, are the same values that go in here. There we go. All right, so try number 3. Go ahead and do number 3, which is same as number 1. Like I said, it's going to be finding the slope and then finding b and then converting that to slope-intercept and c. It's the same question, just written differently. So try that on your own, see how that goes. Check that when you're ready. And much like the first one, we could reverse the difference and figure out the y-intercept just to verify. Right? So same thing here. There's no space for it, but you could always think about this. Okay, if I add 8, what do I get? I get 25. What did I get in my formula? 25. So there's definitely ways of checking this that you could just really fast verify. No calculation or calculator needed. Just quick check. Okay. So can we handle this? Is this good? Keep going. So here's a slightly different representation. It's it's got a little chart just like the first one did. So, and we have one of the numbers given to us. So given this, the subscript notation, or explicit as also it's called, I can write that. Everything, I know it's going down, it's going to be minus. I don't know the differences yet, but it's going to be n minus 1. And that's just from this one, and that's 32. So I know this much, I just don't know the difference. So how do you suppose you find the difference here? All right, well, last problem, obviously we just need 2 points, right? So just to find slope, we need 2 points. But what 2 points should we use? Should we use this second term, third term, fourth term, fifth term, or sixth term? Or does it matter? The which? The first and second? Fifth? Why fifth? Yeah, this is on what's called a lattice point, so these intersect precisely. So if I try to use the second term, I'd be estimating. Maybe that's 27, maybe that's 28, maybe it's 27.5. I can't be sure because it's not exactly on that last point where these two grids intersect. But down here at 5, it definitely looks like it's 12. So other than this being a vertical chart compared to a horizontal chart in the last problem, same thing. So go ahead and do that. The last columns are just straight A sub 2, 3, 4, F of 2, 3, 4. There's nothing, it's just showing the two different representations side by side. So I'll fill this out. So minus 5, 27, 22, 17, and 7. Okay, double check that when you're ready. And try number 5. All right, same question, just written a little bit different. So far we've done really one type of problem several different ways. Keep that in mind. The steps have been the same. Find slope, find the missing numbers, write the general form in subscript notation, and then write it in function notation. So just keep doing the same thing. All right, with little tiny adjustments along the way. And one could definitely keep plugging in numbers, plug in 1, plug in 2, plug in 3, but it might be a little faster to just identify the difference here. Right? And then you can just use that. Okay, it's minus 3. And that way you can finish the list and get to 10 a lot faster than plugging in 1, plugging in 2, plugging in 3, and so on. So use the information that you have. Save yourself some time. So you got 3, 4, 5, 6, 7, 8, 9, and 10. 10 numbers. plus 12 is 21. And what value did you get for b? Negative 579. There we go. As promised, pretty straightforward. Same question, just a little bit different. Right, yeah, we had to pull the d from up here, to really help us out. But other than that, it's pretty much standard as the rest. Let's move it on. We got a couple word problems, and the reason why they are just introducing this word problem, the slope-intercept version, the function notation, is because for word problems it really helps. Usually standard sequences start on 1, right? Like the initial graphs over here. They all start on 1. There's no y-intercept in a sequence because there's no such thing as a 0 term. It's 1, first term, second term, third term, and so on, right? However, with word problems, it does serve us a little bit better to think about as a sub 0 as the first term. And you can play around with it and do it without doing that, but you'll find your answers are always off by 1 because if you're counting from 1 instead of 0, everything is going to appear to be 1 bigger than the actual answer is. So looking at this like May 3rd, and we're going to May 8th, you could say this is a sub 1, and then 5 days later would be a sub 6. But it's a little bit easier just when we're thinking about this to think of this as that's where we're starting a sub 0, and then 5 days later, from the 3rd to the 8th, that's 5 days, that's a sub 5. And it just makes a little bit more sense when you're doing your calculation to think about it this way. So other than that, it's the same thing as you just did. Find out what the difference is by doing the slope, right? Using 55 with 0 and 47 with 5. And you can find the difference. You can find the first 6 terms, not 10 terms this time, only 6. With the first one being 55. So we're counting where we're starting. Even though typically we'd start at a sub 1, right? So it would be the first term, but we're going to include it even though it's a sub 0 as the first term. But do the same exact thing that you did on all the others. Don't think of it twice. It's the same thing. Find the slope, find the difference, find the rest of the terms, and so on. Don't overthink it. Trust yourself. You know how to do this for sure. If not, just look back at the past problems and do the review and then just repeat that process. And yes, you do get a fraction. And ask yourself when you get these fractions, especially in word problems, does that fraction make sense in the context of the problem? If not, switch it. So if someone's saying, okay, this barrel of water is draining, how much is it draining by per day? Negative 8/5 gallons. Right, well, as you guys know, anytime you go to a gas pump, it doesn't give you fractions, right? So a fraction, losing water as a fraction doesn't make a whole lot of sense. So as a decimal, yeah, losing 1.6 gallons a day, that makes a lot more sense in the context of the problem. So it's a judgment call. You could leave it as fractions all the way through, but just ask yourself, what's a little more common sense? So we have to go down by 1.6 each time. So minus 1 and minus 0.6, 54 to 53.4. We'll be at 51.8. We have 50.2. minus that would be 0.86, so 48. And minus 0.6, that would be 47. So this drum, a gallon of rain water that they're using to water the garden is just going down by 1.6. So on the first day, this would be like starting here May 3rd, May 4th, May 5th, May 6th, May 7th, May 8th, and so on. All right, so write an explicit, same thing we did on the past ones. And remember, this time the 55 is a sub 0. A sub n is 55. And we're going minus 1.6 n minus 0. Which, of course, just simplifies to 55 minus 1.6 n. Because the 1.6 times 0 is just 0. Don't have to worry about it. And this makes the function notation quite nice, right? I mean, really the only thing different is you often see the leading number first here with a different second when you're doing the subscript notation. With function notation, it's the opposite way around. So we'd write, commute this over, negative 1.6 n plus 55. There we go. And last one, explain when the rain barrel will be empty. Okay, when will the rain barrel be empty? Assume there's no new rain for the next 10 days. Well, actually, I was going to say no new rain at all. So at some point, it's not going to rain, and then the barrel fills up more. Let's just say it just keeps steadily going down 1.6 per day. How many more days will it take? Basically, if we continue this sequence, how much longer until we end up with 0? Like how many more days? This is 1, 2, 3, 4, 5, 6 days. Right? How many days does it take? So you want the whole thing to equal 0. So does that mean you want n to equal 0, or do you want f of n to be 0? Something has to equal 0. Empty means equals 0. So you have two options. Think about what things stand for. So you can either find f of 0, right? Or you can set f of n equal to 0, the y value equal to 0. So which one makes more sense for this problem? The left side or the right side? Yeah, so the n equals 0, if you just solve this, gives you 55. Yeah, that's what you started with. That's like the y-intercept. So this doesn't tell you anything that we don't already know. So n equal to 0 is saying, like, well, how much water did we start with? You know, after 0 days have passed, how much water was there? Well, we started with 55. That's why we get an answer of 55 when you plug in 0. Where over here it's saying, well, no, f of n equals 0, which stands for how much rain is left in the barrel. So if you solve that, that gives you how many days? So 1.6 into 55 is, thank you, 34.375. So approximately how many days does it take? About, 34 or 35. After 34 days, how much will be left? Yeah, if we use 34 days, there's still going to be this much left, the 0.375. So it's actually going to take us another day, 35 days. So after 34 days, there'll be just a tiny little bit left. And then as soon as we start watering on that 35th day, that's when we'll run out of water, assuming it doesn't rain at all and doesn't fill up at all. Now, when you guys get to calculus, that's when you throw in the, oh, you're watering this much and it's gaining this much in rain every day on average. And how long would it take then? So you add a new little layer of rates when you get to calculus to answer that question. But for now, we'll just say there's no new rain. And now if you really want to be savvy, you can actually calculate what the date is. If we start on May 3rd, what date is 35 days later exactly? So that's extra credit. All right, so lastly, all right, Alan's assigned a book to read for bio, and counting today is Monday as the first day. He finds he must read through page 385 by the 12th day, and then through page 665 by the 20th day. Much like the last one, we want to consider the starting point as the actual a sub 0. Okay. Now, what that does, because usually sequences don't have that, right? They don't have a sub 0. It drops everything by 1. You don't have to do it this way, but it does make the answer a little more interpretable later on. So even though this is the 12th day, this is assuming starting from day 1. But we want to start at like 0. So I'm going to use this 385, and I'm going to just drop it down by 1. So I'm going to say that's a sub 11 instead of 12. So that's a one little new technique you want to think about here. Same thing here. This is day 20. And I've done it both ways throughout the day. And both ways give you an answer, but then this way you don't really have to interpret it later on. Makes things a little bit clearer. So when you're doing your difference, trying to find your difference, you can calculate it just like that. So common difference, same thing. I know it for some reason it asks you the common difference in B, so because you need that in order to do A. You have to find what the difference is. Find the slope. Numbers are a little bit bigger, but it doesn't change the difficulty when you got a calculator. Nine. 35. Which means got to read 35 pages per day. And with that, we can do the general term. You'll notice that we're not given the a sub 1 or a sub 0. We don't know what that is, so we'll have to adjust our formula ever so slightly using the 11. So we'll have n minus 11, and we'll have 385. So slight adjustment. That's why here it gives you this general formula. So we have to adjust these from the standard numbers to the numbers we're actually given. So 385 plus 35 as the difference. And we got n minus 1. No, sorry, 1, 1. Minus 11. And we could use the last one here as well, if you wanted to. Okay. And this gives you the amount of pages that you'll have read after and what? Ah, very good. Good, good, good. I said it, I didn't write it. Go down one by one. Thank you. Not that we need it in here, but yeah, that is technically correct. Good. No, I think I had this already in my mind. So it comes out the same. I said it and I wrote it different, but when I calculated, I used 19. Just got excited. You know this math. So based on how many pages Alan need to read today, the first day, well, we already know it's 35 pages. How do you know? Yeah, just use the formula, and that explains that. Could also say, well, 35 times 11 does give us the 385, so we can confirm our formula actually works. Or you can say times 19 will give us 665, either way. And then using the function rule, how many pages will Alan have to read by Friday's class? So is that a sub 4, or a sub 5, a sub 6? Which one we're trying to find? So one way to look at it, because the language can be somewhat confusing, we're starting on Monday. We're going to Friday. And remember, we started with a sub 0. So Friday is a sub 4. So that you got to be a little careful on that, because since we're starting at 0, even though Monday through Friday, that's 5 days, since we're starting with 0, we're really trying to find a sub 4. That's what Friday is. And then we have 385 plus 35. 4 minus 1. Oh, no. Oh, 1, 1 again. Do that again. 35 times negative 7. And 35 times 7. Minus 245. And we end up with 140 pages. Which we could also confirm just by doing (35 times 4, right? That also gets you there as well. So if we're using the formula, if it says use the function rule, then yeah, you have to use it, but you can confirm it just like, well, yeah, after 1, 2, 3, 4 days, 4 days of reading, you do have 35. And notice the language assumes you're not reading on the 5th day. They say by Friday, which means before Friday. So it's really 1, 2, 3, 4 days of reading. Okay, so when someone said, like, when you guys get your homework, said this is due, well, by Friday, it's assumed that, okay, it's finished the day before, not that you're still working on it like right before class. Because some people think, well, I could read on Friday as well. How do I know which one? So it's just a standard way of interpreting these things. When I say by something, it means before. So keep that in mind, little tiny language things we have to think about. Okay, so there you have it. You have the assignment, yeah? Yep. So take a look at all the problems as usual. Don't start on number 1 and do number 2, do number 3. Look at the front, look at the back, look at everything. Is there anything that's not clear? Ask the question before you leave. We got about 12 minutes.